We are live. Okay? This seems like it might be a short section. We might cover more than one section today, but we're going to cover 4.2. That's fine. 4.2, which is the natural exponential function. Okay? And basically, we're going to talk about the number e. And you all thought that was a letter, didn't you? Okay? The number e is a number 2.7182818. No, goes on forever. It's kind of like pi. You guys know that pi? What's pi? 3.14159.278. I think it goes on forever. It's just an irrational number, just like pi. Okay. The definition of e is 1 equals 1 plus 1 over n to the nth power. That's how they get it. Okay. So you'll notice on your calculator. Well, we're going to be talking about logarithms anyway. You've got a log button, and you've got an ln button. Okay? Log assumes base 10, and ln, stands for natural logarithm, assumes base e. Okay? So e is just a special number, just like 2 or 3 or 4, except for it just has a lot of digits that go on forever. Okay? The two most common bases that we use in math are base 10, that's what our number system is based on, and also base e. Question?
What's underneath log?
ln.
ln.
Yes. ln, I was talking about your calculator. Okay? All right, so you guys probably, what I'm curious is, can you figure out what e to the third power is on your calculator? You should have an e to the x cube. Hopefully you do. In order to figure this one out, you better have a calculator. 20.08544. 085, what is it, 44?
You got
554. Yeah, and it goes on forever, right? Okay? So this section is going to be really easy. It's going to be a repeat of what we did yesterday, only we're using base e for everything. So, how about, let's make sure you can plug it in your calculator correctly. 2e to the negative 0.53 power. What do you guys get? 1.17722. Okay? 2.1. Yeah, you're right. Okay. All right, so now we're going to see how good you remember your stuff on the quiz today. What if I told you to graph I can't spell it today. Y equals e to the minus x. How would you do such a thing, Nathan?
I'll get a graph out.
Okay, I got my graph right here. I'll even use it if you want.
And we're just gonna do a nice little slant upwards.
Okay, what's the 3 things that I should see on your quiz? You can describe
The important
those.
point.
The important point is
0, 1.
0, 1. It's right there.
Horizontal asymptote.
Horizontal asymptote. You should see that on the axis. And does it go from high to low or from low to high?
Let's go low to high. High to low.
You sure?
Yeah.
Which one?
The high to low.
High to low.
Keep it on.
Okay. All right, so those are the three things I want to see. I want to see your asymptote, I want to see the important point, and I want to make sure that your curve is oriented correctly. Why is it high to low and not low to high? Because there's negative on the x right there. Okay? And you could even see that today on today. All right? All right. So, okay, you know what? One thing that we didn't spend a lot of time on yesterday, but let's talk about that, especially since you can see the graph. What's the domain and the range? Let's pick on Eric. I'll let you pick which one you want to answer.
Domain positive infinity to negative infinity?
We usually go negative infinity to positive infinity.
Yeah.
So, but what did you forget? What did Eric forget? That's only worth half correct answer. X is an element of, right? And so you can redeem yourself. What's the range?
Range is 0 to positive infinity
You did it again.
with the y is a factor of 0 to negative.
No, it's not a
Positive
factor. It's an element of.
or element of.
Okay. And
0 with a bracket.
is it like that?
No, I can't remember. Parentheses.
Parentheses. There you go. That's better. Parentheses.
Infinity.
Infinity. Perfect. Okay. All right. Where's the asymptote? Let's ask. Let's see here. How about Caleb? Where's the asymptote? Y equals 0. Okay. I think this is going to be a really short section today. That's good because logarithms are a lot harder. Oh, this looks like a really, really good one. Okay, let's see how good you guys are on your graphing. This is going to be problem number, and I'll even graph it over there. All right, we'll pick a different color. I don't want to pick red. All I have is 3 colors today. This is problem number 16 on the homework. G of x equals minus e to the x minus 1 plus 4. This looks like a good one for Sam.
So x is going to be
Okay, let's talk about your important point first.
okay, the important point.
Okay, so we started here. Which way are we going to go?
It's going to go up.
Up 4. 1, 2, 3, 4. So we're temporarily there. What else
And
moves
then
up
we're
4?
going to go 1 to the right.
1 to the right. Okay.
Yeah, and then the curve is going to go down to the sector 3.
And then what?
The curve is going to go down to sector 3.
The curve is going to go down to.
quadrant 3.
Where's the asymptote? Let's ask that first.
Asymptote is going to be 4.
4, right? Y equals 4 is your asymptote. Okay. Then normally we're going to go this way, right?
Yeah,
Okay. What does that negative do to me?
it's going to go down.
Does it go down?
Yeah,
Or does it? Yeah, it does. You're right. So now my important point's there, right?
Yeah.
So it's going to go like this. That was a good one. Who's studying with Sam? Sam's studying with himself. That's good. Okay? That was confusing, huh?
Can you
So there you
redo
go.
that really quick?
Redo that? Sam, you went too fast. I'm blaming him. How did you do that so fast? Actually, let me ask you this, Derek. You were with us at the beginning, right? We started here. We moved it up 4. Okay. So now we're here. We moved it to the right 1. Now we're here. You were with us to there, right? Now, the problem is, what happened with this negative? That negative flips it over the asymptote. Okay? So instead of being 1 unit above the asymptote, I'm now 1 unit below. Okay? And then normally it would go like this, but it's going to be a mirror image of that. So then it's going to be like this.
And the asymptote is 4 because.
The asymptote is 4 because of this 4.
So if you ever have like a plus added on to that thing, it's going to be the asymptote.
That's going to be the asymptote. Okay? Josh?
Why is your special point always out the 0, 1?
Oh, you missed yesterday's lecture.
Yeah,
You didn't even watch the video, did you?
no.
All the wrong answers.
Okay, so quiz for you. What's e to the 0 power?
That's 1.
1. What's 2 to the 0 power?
1.
What's pi to the 0 power?
1.
You noticing the pattern?
Yeah.
That's the x coordinate, that's the y coordinate. Always goes through that point. That's why we call it the important point.
Yeah.
Okay? We talked about that yesterday. If you watched the video.
I'm watching this.
Okay, Derek.
I did For some reason, I thought that if it was on the outside, that like, you grab it.
Okay. So you're concerned about this negative, right?
Yeah.
How do we know which way it flips? Okay? Let's pretend that it was y equals x squared, and then y equals negative x squared. Okay?
Yeah.
This opens up, right? This opens down. So you flip, there's no asymptote in this case, but you flipped over the axis, okay? So this is always going to flip it in the y direction. Does that make sense?
Yeah.
So since we flipped it in this case over the asymptote. So rather than going high to low, it goes from low to high.
I thought that base to the x meant it would load as high.
Now, if we wanted to, g to the x, g of x equals negative e to the negative x minus 1 plus 4. Everything's the same. What does this do?
What's it?
Flips it which way?
Yeah, side to side.
It would flip it this way, right?
Yeah.
Okay? If I didn't have this negative here, let's leave it here, okay? Normally it would go here, and so now we're going to go like that. Oh, that's really light. I'm sorry, I got a bad marker. I know you can't see that on the video. Hopefully you saw me draw that. Okay? And if you're not sure, what do? Plot points, right? Camilla?
Well, I'm kind of confused with him because isn't normally going that way? So it should just flip over and be down like the red one underneath.
Oh, wait a second. Did I mess up on that?
Yeah.
Oh, yeah. It's normally, oh,
Very confused now.
I did mess up.
Bottom right one.
Oh, never mind. No, who's studying with Sam? Don't start. Here, let's do it again. I think there is a mistake on that. We're gonna do the one here. Okay, he was right on the first parts though, okay? The asymptote's going up for 1, 2, 3, 4, right? So that's clearly right, okay? Then the important point's gonna go over 1. Normally it's gonna go this way, right? Okay? Now, because we've got the negative, we're going to do everything and it's going to go this way. Correct? Okay? So it looks like this. I did draw that wrong. You're right. Okay. That was a really hard one. Okay, now, oh, we are taking up more time than I thought we would. We are also going to introduce a new formula called A equals PERT, P-E to the R-T. This is continuous compounding. Okay? So here's what we're going to do. I want you to compare continuous compounding versus daily compounding. Okay, now continuous compounding, that means every second you're making interest if you're the bank, right? Or if you're investing, okay? So let's compare, and then, so the daily compounding is A equals P times 1 plus R over N to the NT power, okay? So I want to compare these two formulas. We're going to invest, we'll keep the numbers easy, invest $1,000 at 4% interest for how many years do you want to do? 7 years. Okay? We're going to compare the difference between continuous compounding and daily compounding, because remember, we like to compound it more frequently, right? Okay? So this is definitely going to be higher than this, but you're going to notice it's not going to be that big of a difference. Okay? All right, so let's pick on Chris. Can you help me? You want to do continuous or daily?
Daily.
Daily, okay. So the daily, tell me what to write on the board.
7. Wait.
What's P? Are you having trouble seeing?
Could you read it? Sorry.
Invest $1,000 at 4% interest for 7 years.
4 parentheses.
No, your principal's not 4%.
1,000.
$1,000 times 1 plus, what's your rate? Yeah, how do I write that? 0.04 over, how many times are we compounding it? 365 to the and again, N is 365, and T is 7. Okay? So somebody figure out what that is. I just made it up, so I don't know. While we're doing that, we're going to compare that with the continuous compounding, which I think you'll even like better. And let's pick on Max. Can you help me figure out what to write for the continuous compounding?
It would be 1,000
E
to the 0.4 times
7. Okay? Here, I will do these. Hopefully y'all can get the answer here. I'm going to try to pop these on the computer here really quickly. Equals 1,000 times 1 plus 0.04 divided by 365 raised to the 365 times 7th here. Okay, so you should have on your calculator gotten 1323.11. So this is 1323.11. So you've made $323 roughly. That's daily. And continuously equals 1,000 times EXP hopefully that's the right number. I hope that's the right function, to the 0.04 times 7 years. Oh, look at that. What was the difference? 2 cents. 13.23, 13. Okay. So you can make 2 more cents in 7 years. Definitely worth it though.
Right.
Okay. All right. So daily is essentially continuously, but which one was the easier one to plug in? A equals per. Now I'm just going to warn you. We can use this function for more than just interest. And I don't like to remember all the other ones, and I can remember A equals pert, and so I'm going to use it. It works for bacterial growth and all sorts of things. And so just remember P is your starting. You can think of it as your principal every time. So I know we only have 5 minutes left, but I also know that section 4.3 is going to be a lot harder than 4.2. And so I would like to take 5 minutes and get you introduced to logarithmic functions, even if I don't give you any homework. This will save us a little bit of time tomorrow. And I kind of hinted at it at the beginning of class today. But logarithmic functions are inverse functions of exponential functions. Okay? So for example, if I had 3 to the x equals 15, okay? That would be a really hard problem for you to solve right now, right? 3 to what power equals 15? You could do a lot of trial and error on your calculator until you got really close to 15, right? Okay? So how you would do that, how you would write that in a logarithmic notation is let me think here for a second. Log base 3 of x equals 15. No, is that right? No. Log base 3 of 15 equals x. Okay? Now, let me just show you how, so these are equivalent equations. Okay? And so this is really nice because now we can solve for x. Okay? Now, the way I think about it is, let's say that I've got 3 to the x equals 15. Okay? Here's what I would say. You can take the log of both sides. Okay? And there's a rule that says when you do that, you can bring the x out front. Okay? And so x log base 3 of 3 equals log base 3 of 15. Okay? So that's how you would think about it. Think of the word log as like a square root function or a cube root function or something. It's an operator, okay? So log, think of it as an operator. Like a square root is an operator, or a plus or a minus, something like that, okay? So the inverse function, if you want to get the x out of there, so there's 4 rules that I'd love to have you know by tomorrow. And here's the 4 rules, okay? Properties of logarithms. Okay? And I'm just going to warn you, logarithms are probably the topic that students struggle with most in this class. So there's a good chance this might be the hardest test coming up. So this is when you're going to want to get a lot of help. Okay? Question?
Are we able to use our calculators for logarithms? Or would you rather us be able to do it for example?
Yes.
Cool. Both.
I want to, yeah.
I'll take both.
Okay, so can you use calculators on this is the question. And it will depend, back, 5 years ago when I taught this class, they said no calculators at all. Okay, they wanted everything in exact, so the idea here is they have exact answers, which in this case would be this, that would be an exact, or they have approximate. Approximate means you can use your calculator and you're going to get 0.1234 or whatever you're going to get. Okay, so I'm leaning more towards exact. Most of your answers I'm going to want to be exact, but there will be some where you can use your calculator. Okay, but yeah, definitely the math department here prefers exact because it shows you know what you're doing. Okay, so the 4 properties that I want you to know by tomorrow, and I want you to remember them for the rest of your lives. Rule number 1, log base A of 1 equals 0. Rule number 2, log base A of A equals 1. Rule number 3, log base A of A to the x equals x. And rule number 4, A to the log of A to the x equals x. Okay? So those are 4 properties of logarithms. This is really easy. Remember when Josh said, how come it always goes through 0, 1? Well, this is 0, 1. It doesn't matter what the base is. Base 3, base 7, base 20, doesn't matter. Log of 1 in any base is always 0, and I know you like the word always. Log base A of A in any base, log base 3 of 3 is always 1. This is what I told you. You can always bring this out front, and then you've got log base A of A, which is 1. And that's log base A of A. Okay? Quiz tomorrow. Here's what I would like you to do. Quiz tomorrow will only be on 4.2, but I would like you to practice some of 4.3 because I know it's going to be hard. So at least look at it. I won't give you a quiz on 4.3, but I do want you to get used to it because logarithms suck, just so you know. You're not going to like them.
So for calculators, then on the test, it would still not be allowed a graphing calculator, right?
No graphing
So
calculators.
it's just a different one that still runs logs.
Right.